After I put together this talk, I realized that the talk was probably more appropriately titled Changing the Paradigm on Metric Management. So who here does any sort of metric definition, management, building dashboards, anything like that? Raise your hand. Yeah, that's a lot of what we do, isn't it? Think for a second about all the steps that you go through when you're doing that. I'm giving you a little bit of time because if it's anything like where we started at Airbnb, it's probably a lot of steps. This is what the workflow for metric management looked like at Airbnb last year. It's 9 steps. It involves first creating a table, scheduling a job, backfilling that table so you have historical data, adding it to our A/B testing platform, adding it to our dashboarding platform, actually building that dashboard, adding it to our Anomaly Detection platform, telling all your consumers to update their queries and where they can find it, and finally, ongoing work to monitor stuff and fix it if it breaks. If you have to do all of this, when is there time to do anything else? I was a data scientist. I actually started at Airbnb as a data scientist on our growth team. And this is what I did all the time. And it drove me nuts. So I actually switched teams and roles to fix this problem. Hi everyone, I'm Lauren. I am a product manager on our data platform team at Airbnb. Like I said, I was previously a data scientist. At Airbnb, our mission is to make sure that anyone can belong anywhere. And one of the main ways that we do that is helping hosts connect with travelers who are looking for places to stay. This here is a picture of one of my favorite listings that I stayed at. It's near Salinas in Monterey. My hosts included 2 very friendly llamas, 2 very nice sheep, and a very thoughtful woman named Susan who literally missed nothing. It was a great experience, highly recommend it. And I'm here today to tell you that you can change the paradigm on that metric management workflow that I just showed you. So today at Airbnb, this is what our workflow looks like. It's 2 steps. It takes about 1/10 of the time as that previous workflow that I showed. And actually that second step of creating dashboards, we semi-automated it, so that also is way less annoying. So today I'm going to walk you through how we did that, starting with where we started at Airbnb last year, why we decided that for us, dimension should be front and center in our metrics platform, and why if you're tackling this problem at your company, you might consider that too. And finally, why we chose to prioritize features for our metric producers, our metric creators, very early on, and why you might want to do that too, so you can make sure that this is actually adopted and used by your data scientists at your company. So where do we start? Like many companies, we had a plethora of tools for managing metrics and accessing metrics. Starting on the right here with Airflow, which we've heard a ton about in the last day and a half, a very popular job scheduler that came out of Airbnb. We use Superset for our dashboarding purposes and for metric exploration. There was a great talk by Max Peshemin last year at this conference, if you want to look that up. We have an anomaly detection platform so that if there is something wrong with your metrics, you get alerted. Or if there's a substantial change in your metrics, you get alerted. We have an A/B testing platform, and we have a tool called Dataportal, which also has talks available on the internet if you want to learn more about it. This is a tool that allows anyone across the company to search for data and find what they need. This is all built on top of a strong open source-based compute environment. In particular, we use Hive, which is a distributed SQL engine, Presto, which is a faster distributed SQL engine, And Druid, which there was also a talk about last year, so you can look that up. Druid is a data store that actually does all the hard computational work when you load the data in. So for slice and dice analytics, you get really fast returns on your queries. And we leverage that a lot in our metrics framework. In addition to the workflow pain points that we talked about earlier, there were also pain points with consuming metrics despite that plethora of applications. First of all, metrics couldn't be reused across these different platforms. The data scientist had to individually onboard them via config to every single one of those systems. And this isn't just a pain point, actually. This is a real problem for the business because it results in discrepancies in the data between these tools. And that degrades the trust in the data and can actually lead to bad decisions. And we saw it leading to bad decisions across the company. Additionally, metrics were hard to find, despite the fact that we have Dataportal, which is an amazing tool for finding data entities that exist at the company. The best that you could do was find a metric or find a table or a dashboard. You didn't know how to aggregate the data from that table if you weren't previously exposed to it. A lot of things lack documentation. And finally, after you found that table, if you didn't know SQL, you were screwed. And then you had to have a data scientist prepare a dashboard for you. And we actually surveyed people across the company about whether they had access to the data that they needed to make good business decisions. And one of the top complaints was actually lack of access to data scientists. This isn't the kind of work data scientists like to do. They call it fetch work at Airbnb. So we knew that we had a real problem we needed to solve. Between these pain points with accessing metrics and making decisions based on them and the workflow stuff that we talked about earlier, this was causing real problems in the organization. So we built a global metrics framework. It sits on top of all the tools that we talked about before, unites them together, and allows for high leverage in the business by reducing redundancy, which sounds redundant on its own. And today I'm going to tell you some lessons that we learned as we built this. So what is global metrics? We define global metrics as the concept that you should define your metric in one place only. That it should be available in all the applications where you need it, and that there is enough documentation and metadata associated with those metrics that when you access them, you know what to do with it. And if you have a question about it, you know who to ask. So as we started to build this, we had a question about whether we could reuse existing infra or how this fit into some of the other products we had at Airbnb. One existing piece of infrastructure was a ML feature repository built by our ML infra team. And we thought that maybe these are similar things. Conceptually, a metric and a feature are not that different from each other. You use things that could be metrics to describe your business as inputs to models or as the output of, or the thing that you're training on frequently. And naively, on a high level, these look the same. You need to have a config layer to store that logic and the metadata associated with your metric or feature. You need to have a compute layer that calculates it. And then you need to serve it to all of your metric consuming applications or feature consuming applications. In the case of ML models, these consuming applications are models, such as our pricing model and our fraud model. And in the case of metrics, these are the applications that we talked about before. But after sitting down with our ML team and arguing about it for approximately half a day, we've discovered that they're pretty different, actually, that there are some different requirements of these frameworks. For metrics in particular, you want to leverage as much information as possible in order to understand user behavior. And sometimes that can include future information that you don't have at the time that the event you're basing that metric on occurred. For example, a lot of our users are logged out when they access Airbnb, and we want to know if they're going to convert to bookings. So we want to go back to the beginning and convert to say that that logged out user was actually this person who made this booking 5 days later. Additionally, our metrics are needed entirely offline. There's really no online use case for a metric. That leads to different compute requirements. And finally, there are a lot of types of metrics we wanted to support. So in addition to the fact that like standard metrics, most of them you just sum over like the number of times a user clicked on something, or at Airbnb, the number of times they booked a listing. There are also the idea of conversion metrics. So how long did it take for that new listing to get its first booking? We also frequently use ratio metrics across the company, where the numerator and denominator could be from entirely different data sources. On the other hand, ML features had their own requirements. So unlike where we wanted to know as much information about our metric as possible, for ML, you have a very strict requirement to prevent data leakage. You do not want that future information polluting your model, and because that can degrade the output and, if your model's in production, the user experience. In addition, ML features need to be available both online and offline, leads to a need for variable types of compute. And finally, they have their own complex types of calculations that they need to support. So between all of these things, we decided that they are fundamentally different problems that need fundamentally different infrastructure to solve. The basics are similar, but the details are different. And the things that are powerful about these frameworks are really those details. We actually are beginning to come back around to revisit this decision now that the global metrics framework is built and up and running. We realize that this can actually be an upstream input data source for our ML models. And we're beginning to think about how that integration might work. So one of the things that turned out to be pretty different between our ML feature requirements and our metric requirements was the requirement for how they handled dimensions. So at Airbnb, turns out dimensions are really important. And there are a few reasons. And I think that they're going to be extensible to a lot of other companies. So first of all, a lot of the metrics we track across the company are actually just dimensional cuts of other metrics. Second, a lot of our metrics have hundreds of dimensions that people might care to cut them by. And third, we strongly believe in denormalization for analytics purposes. So you might ask, why do you believe so strongly in denormalization for analytics? And it's because it makes it so much faster. Also, makes your data much more reliable. Because if you have a normalized data model, like what is shown at the top here, every time you access that data, you need to remember how those joins happen. And you need to pay for the cost of compute right then. So it takes much longer to execute that query and get your result back. And frequently, you just want to know what that answer is. But if you have a denormalized model, like what's shown at the bottom, the data's all there. It's easy to do your group bys and filters. And it's especially much easier for less technical folks, like our product managers, who are frequently accessing this data to make decisions. Additionally, like I said, for this framework, we decided to leverage Druid. And Druid doesn't let you do joins. So it was a fundamental limitation. We had to denormalize all of our data. And the reason that Druid doesn't let you do joins is because when the data is loaded in, it's aggregated. So here's some example dummy data that you might see in Druid. And you might notice there's a timestamp column, some dimension columns, and a metric column. But what's missing is an ID. And that's because you don't get that performance if you load in atomic data. You would have to still pay that compute cost at the time of querying it. So, like I said, another reason that we needed to handle this dimension question was because a lot of our metrics at Airbnb are actually just dimensional cuts of other metrics. For example, as a company, we look at bookings. But the growth team looks at first-time bookings. Our China team looks at bookings in China. And our Airbnb for Work team wants to know about how many business trip bookings there were. And apologize for that. So these are really just dimensional cuts of bookings. Additionally, these are the metrics they track, but the power comes in when they're able to do ad hoc exploratory analysis, cutting by any arbitrary dimension. So people don't just want to know bookings in China. Today they might want to know bookings in China from North America by host status. Tomorrow they might want to know bookings in China by platform. Arbitrary dimensional cuts in order to understand what's happening in our business. So in order to solve this problem, we turn to a familiar concept in data warehousing that many of you are probably familiar with. We look to star schema. And in a star schema, it's centered around fact tables, which are tables of atomic events, basically where your metrics live. And these join to dimension tables on foreign keys to bring in that additional context. For our global metrics use case, we renamed these things a little bit. Our fact tables became metric sources. Our dimension tables became dimension sources. And we renamed the foreign keys subjects. Part of the reason we renamed these things was for consistency with our other internal tools. For example, subject is a term that was already used in our A/B testing platform. But another reason that we renamed them is because in our framework, these aren't tables. These are actually YAML-based configs. So this is the layer that our data scientists interact with. This is where they're going to be doing all their work from now moving forward, or at least metric management work. So let's take a look at a sample metric source config. For example, the config where we define our key metric, bookings. And you'll notice that this config contains two metrics, bookings, and the number of nights there were in each booking. There are three subjects associated with it: listing, the host, the listing that they're staying at, the host who has that listing, and the guest who's actually going to stay there. And then the data scientist has specified three dimensions that they want to be able to cut these metrics by. And in our framework, this is all the data scientist has to do to bring in that metric. Because what the framework does is it looks for where those metrics are defined in a dimension source configs and automatically does that join on the right subject. This way of defining dimensional joins provides a huge benefit. It introduces rigor. It makes sure that every time a dimension is used, it's used exactly the same way and the way it's supposed to. It provides consistency, and it's a whole lot less work than specifying that join yourself. So the next problem that we had to tackle was that some of our metrics, in particular bookings, literally has hundreds of dimensions across the company that people want to cut it by. And these dimensions are different. Different teams care about different subsets of these dimensions. And some of them might be really expensive. For example, our host team wants to be able to cut their metrics by the lifetime value of the listing that was booked. This dimension is the output of a machine learning model. So itself, it takes a long time to compute, and it lands later in the day. So if we waited for this dimension and all the other dimensions that we needed to show up in order to land bookings data every day, that would be a big problem for our company, because every team in the company would have to wait until after work hours in order to understand the number of bookings that happened yesterday. So to solve this, we introduced a concept called dimension sets. And these dimension sets give our data scientists control over their own SLAs for their their section of that metric and the dimensions associated with it. So instead of just specifying a list of dimensions in our config, we now have a dimension set section. The China team can define their own dimensions, shown here in purplish. And the host team can define their set of dimensions, shown here in yellow. And we automatically create two different tables. One table for each dimension set. And the metrics are in both of those tables. And if a new team needs to be able to cut their metric by a different set of dimensions, they can just add a new dimension set to this config. Just a couple lines of, not even code, a couple lines of YAML config, and we'll automatically create another table for them and load this table into Druid so that it's there for super fast slice and dice analytics. So we've actually started to think about our metrics framework as a denormalization machine. This is why it has become so powerful in order to be able to make quick decisions and understand what's happening in our business, because now every team is empowered to cut, to be able to look at the metrics they care about, cut by whatever dimensions they want. They can produce these tables by just writing a couple of lines in a config, and within a day, the data is there, populated, backfilled, ready for them to use. So we started with a very complicated 9-step workflow by just adding in the basic functionality that we talked about now on like how we auto-generate tables from these configs. We've eliminated 3 steps. Admittedly, we added one more, writing the configs. But the next thing that we did was we hooked up all these tables that were auto-generating and leveraged the metadata that we capture in those configs, which I stripped out in our examples for simplicity, to our metric-consuming apps. So we were able to, right off the bat, eliminate 3 more steps. And now we're down to 4. So next, I'm going to tell you about how and why we prioritize some what you might call special features for metric producers before we officially launched this, and why this was really important for adoption for us. And in the process, maybe we can eliminate a couple more of these steps. So we have a saying at Airbnb: love drives growth, not the other way around. That applies to our internal tools as well. So to that end, we built a whole bunch of features that basically gave free stuff to our data scientists. First, we automatically detect when you add a new metric into one of these configs, when you change the logic that calculates those metrics, when you add a new dimension, or when you change the logic that calculates those dimensions. And we automatically do that backfill for you. We heard today a little bit of talk earlier during the keynote about data versioning and model versioning. This is our first attempt to have that concept at Airbnb. We basically hashed the configs to see if there was a change. We store that hash as alongside the data so that we can know which data goes with which version of these configs. Second, we added self-healing properties to the pipeline. So pipelines don't always run. There are issues. When there's an issue in our compute environment or an upstream table gets delayed, the data might not land for a couple days. Data scientists hate going into Airflow and checking off boxes. Data engineers hate that too. Like, nobody likes doing that. So every time the pipeline runs, it checks to see what data has been computed. If there's a gap in the data that's been computed, it automatically fills that in. And third, since we had so much metadata in these configs about what metrics are being created and what their purpose was, we were able to write a script that auto-generates superset dashboards. So this isn't integrated into the pipeline. It's still a sort of one-off task, but It now takes a data scientist about 2 minutes to build a dashboard, whereas if you were going to point and click in Superset, it could take you an afternoon. So these additional bonus features let us eliminate 2 more steps and really reduce this last step to just a couple minutes. So as a reminder, this is where we started. It was tedious, complicated, and if you were, like even simple changes took about 2 weeks to execute. This is where we are today. It's 2, really 1.5 steps, and it takes less than 2 days. And we really have driven love. So by one of our earliest adopters, we partnered very closely with data scientists as we started building this out in order to make sure we were building exactly the right things. One of our data scientists said it has dramatically reduced their time to insight even before they had all these like nice bonus features. Another data scientist was just blown away by all the data management features and is like shouting from the rooftops about how trivial this is now. And my favorite quote, literally got this one. So at the time of official launch, which was actually just last week, we already had over 20 teams who had contributed metrics. Over 350 metrics on the platform, not even including all of the dimensions that I just talked about. And we have less technical folks, like folks from finance, banging on the door asking how they can do it, learning Git so they can contribute. And of course, we added adoption metrics as a metric into our framework. And this is just a little gift to show you how speedy it is to interact with these metrics in Superset. Oops. So just breaking down a total number of objects in our framework by the type of object it is, whether it's an event source, a metric, or a dimension. So I just walked you through how we changed that paradigm at Airbnb and some lessons that we learned along the way that I hope maybe if you're tackling these problems, you can apply at your companies. And why early on, it's really important to prioritize features that data scientists, that metric producers love, so that loads up metrics onto your platform. The next thing that we're working on is building out more features for our metric consumers. Because now we have 100 or 350 metrics plus on the platform, we need to help people find them. So we are doing integrations with Superset in order to surface that metadata, help people know what they're looking at right where they interact in Superset. We're integrating with the tool Dataportal that I told you about earlier so that people can search for a metric by name in Dataportal and easily find it, be able to do deep dives from there. And finally, we're going to add a metric certification process so people can feel really confident when they find those metrics, that this is a quality thing. The other thing we're starting to think about is open sourcing this. So you might have noticed that we built this on top of a bunch of really great open source tools, 2 of which came out of Airbnb. And this framework actually really nicely ties Airflow and Superset together, and we're building a whole bunch of additional functionality into Superset in order to support this. So we're starting to think about how we might go about open sourcing this. If you're interested in talking about this or partnering on open source, we would love to talk to you about it. Come to office hours, chat with us. If you have any other questions about this framework, how we built it, come to office hours. Happy to take them now. You can also hit me up on Twitter, LinkedIn, or email. And I also just want to shout out to Amit, who is the engineer who did most of the work. He's here today, and he can also answer your questions. So thanks so much, and I'm happy to start taking any now if we have time. Cool.
Questions, anyone?
So in the metric definition, where you have dimension set, where any team can add that. So how you avoid duplicate, so it is possible that, many different teams are, partitioning by the same dimensions.
Yeah, so I think your question is about how do we make sure that people aren't duplicating stuff. So this is a big worry we have. And right now, the process is I personally review every single metric that gets added. Obviously, that doesn't scale. So what we're starting to do is we're starting to train a point person or 2-point people from each data science team in order to look for the things that I've been looking for, to make sure that there isn't duplication, to make sure that they're leveraging the dimensions in the right way, because we need to shift the mindset of our data scientists from doing those joins themselves. And so we're going to have point people on each team who will review stuff and also run trainings for their team so that they know how to use it most effectively.
Thanks. So there are certain dimensions, that can have high cardinality. How, because in that case, the job becomes super expensive. How we can avoid it. Where is the threshold for that?
Yeah, so this is also a huge concern. And this is actually the second reason we came up with the concept of dimension sets, because you lose all of the goodness of Druid when you have high cardinality dimensions, and all of a sudden you have super high latency queries, and that's no fun. So what we encourage people to do is to separate out those super high cardinality dimensions into their own dimension sets, so that they're still available, but sort of in their isolated own world, and they don't impact all the other things.
I can talk really loud. Does that work? We're looking for the recording. Yeah. Thanks for an awesome presentation. My question is, if I'm an application developer and I need to get access to those metrics, do you publish it anywhere, or is? Okay.
Yeah.
I think you got it.
So right now, we publish the data in tables in Hive. It's ugly for people to query ad hoc, so we put some nice views on top of it to flatten out and make it look like what data scientists want. And we are loading the data into Druid. The next step is to package our config parser and together and make an API that is actually accessible to people building other applications. Right now, people are either accessing that data directly from those Hive tables, or they are leveraging the config parser in a sort of ad hoc way.
Similar question, but kind of at the other end. If I'm an application developer and I need to make the system aware of new facts or new dimensions, how does the metrics, global metrics framework become aware of that stuff?
I'm not sure I completely understand the question. Are you asking about how do new facts and dimensions get added in so that they flow through the pipeline?
Let's say, for example, if you build a new feature and all of a sudden there becomes a new entity type, experiences is a new feature that was recently added. How does the global metrics framework become aware of that stuff?
So we're kind of, it depends, I guess, is sort of the question. So if it's a whole new data set or new metric or new dimension, all that is configurable, and your data scientist, or we have engineers contributing too, whoever wants to add that entity into the system can go in and add it. If you have, say, a new value flowing in as a dimension, we give you the option of having data quality checks to make sure that those dimensions have the expected values in them. So if you have taken that option, you're going to have to go in and now whitelist that new entity. But that's flexible for whoever is defining that.